Hello everyone, welcome to the course of Computer Organization and Architecture. And today's lecture basically we will talking about what is unsigned representation. So let's first understand the basic things. When you write a number, a positive number in decimal, suppose that you write 5, then you don't need to write any positive sign before that. But when you write a negative number, suppose a minus 5, then you have to put the negative sign before that number. So this is basically a convention we follow. So same way in different types of number systems, there is some rules, there is some regulation we follow to represent a number in a decimal, in hexadecimal with a positive sign and negative sign. So same way we will discuss in our binary number system. Okay, so how basically we represent a binary number. So through this hierarchy, you can understand the things easily. So binary number representations are categorized as unsigned representations and assigned representation. So basically in unsigned representations, it is applicable for only positive numbers, and signed representations are applicable for as well as both positive and negative numbers. Further, sign representations are categorized as a sign and magnitude, where sign basically having a sign bit, that is a sign flag, and for a magnitude there is a magnitude bit. Okay, so and also as categorized as 1 is complement and 2 is complement. So in this lecture, basically, you will understand what is unsigned representation. Okay, so let's understand the basic things like what is a signed number, what is unsigned number. So now, what is unsigned numbers? So unsigned numbers no have any sign. Okay, so it don't have any sign. It only contains magnitude. So the positive numbers only are in the category of unsigned numbers. And now, what is signed numbers? So you know that sign number having a sign bit. Okay, so it contains a sign flag, which is basically a single bit used to store the one bit, and it contains both sign flag, that is a sign bit, and also for magnitude or magnitude bit, and it is applicable for both positive and negative numbers. Now, unsigned representation. So what is basically unsigned representation, and what are the some conventions basically we follow in unsigned representation, and what are certain constraints, or we can say that the limitation in unsigned representation. So first of all, we consider 0 as an unsigned number. So here 0 is also unsigned number, because in binary number system there are only two digits. First one is 0 and another one is 1. So here 0 is also unsigned number. Now another point is that unique binary equivalent form. That is, suppose that if you want to write 3 in a binary, that should be 1 1. So that 1 1 is equivalent to only for 3, not for 4 or 5. So this is unique. And now there is another point is that is a range. So range of an unsigned number is vary from 0 to 2 to the power n minus 1, where n is number of bit. Suppose that if you have a number of bit is 3. Okay, so first of all, what is the maximum possible a binary number in 3 bit? So we have only two digits in binary, that is 0 and 1. So that maximum number is 111. So this is basically in decimal 7. So this is the maximum possible value of 3 bit, and what is the minimum possible value with 3 bits in binary is just reset the all bits, that is 0 0 0. Okay, so this is basically in decimal is 0. So here you can see that range is from 0 to 2 to the power n minus 1. For n is equal to 3 here, so 2 to the power 3 minus 1, that is 7. Suppose that so what is basically this meaning is that Here you can see that it's from 0 to 7, that is the maximum value in 3 bit you can only store 7. Okay, and the minimum value is 0. So all the value from 0 to 7 in an integer value can represent by 3 bit. So suppose that if you want to just represent a number, suppose that is 8. Okay, so you cannot represent 8 in 3 bit. Okay, you have to take an extra bit also. So this is basically a certain limitation. And now there is a concept is that 4 digit format representation. So it is basically very important in digital electronics and computer organization and architecture. So let's little bit brief about this representation. Okay, so here first of all, this is a standard way of representation. Okay, generally in digital electronics and computer organization and architecture, we represent a number from any binary form is in this form. Okay, and here there is a concept of code. Okay, so that is basically a different types of code. Suppose that weighted code. So here in a 4 digit representation, normally the most famous code is weighted code is 8421, and where we have to write the bit the weight of each bit. Okay, so here the bits are 8421, the weight of the bits are 8421. So this is weighted code basically we use in 4 digit representation normally. There are all others any others code basically we have, but generally we use this weighted code. And now what is the process to write a number in 8421 weighted code format of any decimal number into a binary? So first of all we just write the weight of each bit, and after that we set the bit, that is put 1 under the suitable weight. So let's understand by as an example. So here you can see that, suppose take an example like 5. Okay, so 5. So for 5, what is the suitable weight for 5? So here you can see that when we add 4 plus 1, so when we add 4 and 1, it gives you 5. So this is basically the suitable weight. So what we will do, we will just put down 1 under that weight in front of that decimal number 5. So here this is basically 101. So in 4 digit representation you represent 5 as 0101, and we have to just put 1 in such a way that after the sum of that given position of that weight should be a decimal number. So this is the end of this lecture, and thanks for listening. And if you like the video on computer organization and architecture, so please do subscribe the channel and share with your friends. And in the next representation, basically we will talking about what is a sign representation, and God bless you all.